Reactor controller is an excellent solution for connecting the foot roll to the foot roll spinner. Wire parameters would be a little more awkward here. We'd need a lot of if statements to say that as the value goes up, that it should be only rotating a certain bone until a certain point in time, and then after that it should start rotating the next bone. It is also very difficult to get a smooth transition with if statements from one bone to the next. So what we need to do is we need to find a way to be able to get a smooth transition all the way from the heel roll down into flat, up into the ball of the foot, and then onto the toe, so that one motion blends nicely into the next. Reactor controllers will provide us with that. For the toe wiggle and the knee, we're just going to be using wire parameters because they're not nearly as complicated. So starting with the foot roll, let's start by selecting the three bones that will be involved in the foot roll and adding 0 list controllers to them, or in this case using the freeze transform Alt right mouse button quad menu option. In the motion panel, open the Assign Controllers window. Open the rotation of the objects and find the 0 Euler XYZ rotation. We'll be working on the local pivot of each bone. In this case, it's going to be the Z-axis for each bone. I'm going to add all of the reactor controllers first and then work with them. So I want to pick the Z rotation track of the 0 controller, and I want to pick the float reactor, and I'm going to do this for each of the Z tracks. That will be for the toe. This will be for the ball of the foot. So essentially we have heel rotation, ball rotation, and toe rotation. The track they're all going to be reacting to is going to be the foot roll. So I'm going to say react to, click on the foot control, and then in here, modified object, attribute holder, foot controls, foot roll. I'm going to add that track to the react to each one. As soon as you add a react to object or track, it sets up the first reaction. The first reaction state is its current state. The next thing I'm going to do is I'm going to animate the foot control value going through its full range of motion so that I don't have to be constantly changing the value. I can just scrub the time slider. So we're going to start off with a -90, which is going to be the full heel roll. At 20, we're going to go back to 0. At 30, we're going to go to a value of 45, and that's going to be the ball of the foot rolling up. And then at 40, we're going to go to 90, and that will be the full toe roll right up into the toe. So if I scrub this time slider, once I have it all hooked up, we should have a full foot roll. Don't need animate turned on anymore, so I'll just turn that off. Slide along to frame 10, where we're at -90. And for the heel, I'm going to say create reaction now. And a new reaction is added at the value of the foot roll. And I can simply change the state value to whatever I want now. And that will give me the state that it's going to be at that given point in time. So in this case, I'm going to rotate the foot right up at about a 90-degree angle. Let's make it 1.5 in the state. You might say this is way more than you'd ever need, but that's the best thing to give your animators, is more than they'd probably ever need. You can see now that when I scrub back and forth between frame 0, 10 to 20, I get a heel roll. But nothing continues happening as the values go up in the foot roll spinner. At frame 30, the value of 45 in the foot roll spinner, I'm going to go to the ball roll reactor and say create reaction. And then I'm going to set the reaction state for that. And I figure it should be about that high. You can find out later. I'm going to go along to, you can test that happening now. Go along to frame 40 now. I'm going to say create reaction. I'm going to roll the right onto the toe. And I want this one now to actually drop back down, so I'm going to create another reaction for the ball. And this reaction should be back to a value of 0 now. When I scrub back through, you can see that it steps from one to the other. Only problem is that the toe roll is starting right from a 0 value. It's because we never created a value for it at 45. What I'm going to do to solve that is I'm going to add a new reaction at frame 30. It comes in at a value of negative 0.54. I'm going to 0 that value, and that will stop that from rotating. So now from 0 to 10, I get a heel roll, and back down again to 0. To a value of 45, I get the ball roll, and it continues up into the toe roll, and it actually flattens out the ball roll at the same time. So I get this nice blending action. Now it still has a step from one to the other. It's basically a linear interpolation from one to the other. What I can do now is I can actually set the curve types in each. Curve types will actually be nice because I can say ease in and ease out. So select curve in the heel. The heel is actually going in a positive rotation value, although it's negative in the spinner. I'm going to set it to Bezier corner and make it do a nice ease in. Curve for the ball of the foot, I'm actually going to set to Bezier smooth in the middle, and set both of these to an ease out and an ease back into the value. And then for the last one, I'm going to set it to an ease out as well. So now what I'm getting is when it rolls backwards into the heel roll, it slowly accelerates back, but as it comes back down, it sets itself down smoothly, ramps itself up into the ball roll, slows itself down as this one takes on and slowly ramps up, and the ball roll ramps itself back down again. So now we actually have a much smoother reaction from one to the other. You can even make further changes by overlapping the reactions so that the ball roll is still continuing as the toe roll goes up in a positive fashion. You can actually blend them together really nicely this way. We don't need any more of the reaction controllers because we've set all this up. We can go about setting up the toe now, setting it to the toe wiggle spinner. I'm going to pick the toe bone, again with Alt right mouse button, freeze transform, and freeze the transform for it so that I know it has a 0 value. Right click on it, pick wire parameters, transform, rotate, 0, and I know it's the Z rotation again. Pick the control object, modified object, attribute holder, toes. I'm going to have the toe spinner control the rotation of the bone and say connect. And let's check this now. I would assume that if we made this a positive value that our toes would roll up, and it does. But if you notice something strange here is that the bone moves way faster than the spinner does. We're not even at 90 degrees, we've gone around many times. This is because rotations in Max are calculated in radians. And we're looking at the spinner as a value in degrees. What we need to do is convert one to the other. So before the expression, in the expression window in the wire parameter, we type deg2rad space toes. So deg2rad converts the degrees to radians. Say update again. And now you notice that the toes rotate at a speed that we would assume based on the value of the spinner. For the knee, to get this to control the knee swinging back and forth, we're actually going to control, I'm just going to open the motion panel here. I'm going to select the IK solver, and we're going to control the swivel angle of the IK solver. That's basically changing the solving plane for the IK solver. So I'm going to wire this value back to this value just to make it easier on animators to get to all the controls so they're not having to dig for things. Select the IK solver, wire parameters, swivel angle, pick the control object, modified attribute holder, foot controls, knee. Knee is going to control the swivel angle. I'm going to say connect, and let's test our control and see how it works. And once again, you can see it rotates much, much faster than you expect. deg2rad again, and say update. And as expected, a positive value is rotating the knee outwards. If it happened to go the other direction, we could put a negative in front of knee, and it would change that. So what we have now is a full foot completion. We have a foot roll that allows us to roll the foot all the way back, all the way forward with one given spinner. We can wiggle the toes up and down, and we can swing the knee from side to side. If you wanted to make this a really complete rig, I would also provide a separate spinner for each of the heel, toe, and ball rolls so that the animator can completely control them. It doesn't have to just use the automated foot roll spinner. And as well, of course, like I said earlier, separate toe bones for each toe, and then use reaction controllers on each of the joints to be able to get the kinds of movements that a toe would do.